Hi, welcome back to Structural Analysis Made Fun and Easy. This is example problem 0, another example from Linear Analysis of Structures by T.R. Graves Smith. So this is diagonal type truss all at 60 degrees. Doesn't have any, he hasn't put the length in meters, it just says, there's not actually any marking, there's no dimensions of the lengths given, it just says all the members are at 60 degrees. So from that, I've just worked it out myself. So we've got A, B, C, D, E, pin support at A, roller pin support at D. And then we've got a 5 kilonewton vertical download at B, and a 10 kilonewton vertical download at E. And then, so we got from A to B is L over 2, and then from B to C is L over 2, C to D is L over 2, D to E is L over 2. Then we got from A to C is L, and from C to E is L, from B to D is L. Oh yeah, I guess from A to B must also be L, but I didn't actually need that dimension. Just do the quick test on statical determinacy. Remember, M plus R must equal 2J. So we got M, 1, 2, 3, 4, 5, 6, 7, plus 1, 2, 3 joint reactions. And then that, so that's 10, 1, 2, 3, 4, 5. And 5 joints, 5 times 2 is 10. So it's all right. We can solve it. By inspection also you can see we've got 3 reactions. 3 reactions. 3 reactions. 3 equations of equilibrium. Okay, so I've done the equivalent linear diagram representation of the structure. Oh yeah, that was so we take moments, if you take moments about A, that little diagram there is just the lever arms, actually the equivalent linear diagram representation of the lever arms of the forces, because moments about A, so we got minus 5 times L over 2 minus 10 times 2L plus, what was it again? Oh, should that be, oh, it's 1.5L, yeah, or 3 over 2 L times, sorry, that should be D, RD. So 1.5L RD equals 22.5L, because it's minus 5 times L over 2 is minus 2.5L, and minus 10 times 2L is minus 20. Therefore, minus 20 minus 2.5L is 22.5, and then take it to the other side is 22. That means that I've got the direction of RD is correct, because I said RD is positive, that's clockwise, and the other forces are clockwise, so they're negative. The other moments, so RD equals 22.5, oh sorry, 1.5L RD equals 22.5L, so cancel out L. RD equals 22.5 divided by 1.5 equals 15 kilonewtons. Oh yeah, so that's 22.5 over 1.5 is 45 over 3. That is equal to 15. 15, 30, 45. So RD equals 15 kilonewtons. External, oh yeah, so we've got vertical equilibrium now. Externally, oops, oh sorry, I've ripped, oh my god, sorry. Oh. External vertical equilibrium, RA up plus RD up minus 10 minus 5 equals 0. Insert RA into this equation to find RD. RA plus RD equals 15. As RD equals 15, RA equals 15 minus 15 equals 0. So it can be seen that RD is 0 because the structure is balanced about RD. RE, if you look at the forces again, 10, point load of 10 times L over 2 equals 5 times L. So that's 0. 10 times L over 2 is 5L, and 5L, if you take moments about D, just the forces, the moments, you've got, 10 times L over 2 minus plus 5 times L. So they're balancing. So it's balancing about the support D. For the purpose of this video, for the purpose of this video, I'm going to check by taking moments about D. So minus 3L over 2 times RA plus 5L minus 10 times L over 2 equals 0. 3 over 2L RA plus 5L minus 10 over 2L equals 0. 3 over 2 RA equals plus 5L minus 5L equals 0. That means that RA equals 0. Then the no other force, the checks out okay. HA equals 0 since no other external horizontal reactions, no other external horizontal reactions. Oh yeah, for external check, HA, yeah, I've done that same again. HA equals 0, no other external forces or reactions in the structure. So now we move on to equilibrium of joints. Commence at joint A. I think that's right, isn't it? I know, I said, hold on, sorry. I initially said begin the equilibrium of joints at A, but as you can see, I then found out can't start at joint A as we have two unknowns in two equations of equilibrium. So we must start at joint A because, yeah, we can't start at joint A as we have two unknowns. AC and AB are both unknown. I think that's right, isn't it? It's possible there's 0. Oh, it must be. Yeah, so they're actually 0. Oh yeah, 0. Sorry, you could have. We can start at we can start at joint A. I'm gonna just carry on though because this shows you that even equilibrium of joints can be quite difficult. I mean, because if you think like, if you take vertical, if we just say, have another look at it. Let's look at it again. So the vertical equilibrium, RA up is 0. And then AB coming in, AB is a diagonal, and there's only one diagonal. So that must mean the vertical component of AB is 0. So AB equals 0. And then because HA is 0, AC. So in fact, AC and AB are 0, which should be confirmed. Which should be really confirmed. I guess that makes sense because RA is 0, they're not doing anything. Those are 0. You see, because, yeah, AB and AC. So, what I first originally said, it shows you everyone makes mistakes because I've put we can't start at joint A, but we could actually. Because vertical component of AB equals 0. Yeah, it has to be. That means the horizontal component of AB equals 0. That means AC equals 0. And anyway, so I think that will be, I'll show that in the next video. Joint E, by inspection, oh yeah, so we've got pin joint E with a 10 kilonewton downward point load. Then we've got obviously compression in DE, tension in CE, which by inspection that is, isn't it? Because if we've got a point load down, 10 kilonewton down, then compression, then the vertical component of DE must be upwards. That means the horizontal component of DE must be from left to right. That means that CE must be right to left. That's tension. Yeah. So here I am working out, I'm working out the geometry, DE, the 60 degree, 60 degree, 60 degree. That diagram's bad, but it's just to show HDE, VDE and DE. HDE, that's 60 degrees on the inside and then 30 degrees to the 10 kilonewton. So sine 60, which is also like this, isn't it? Sine 60 equals VDE over DE. Therefore, VDE, VDE is 10 kilonewtons because the vertical equilibrium 10 is VDE. VDE minus 10 equals 0. VDE equals 10. DE, that what I said, DE equals VD over sine 60. Right. I need to I'll quickly figure that out in a minute. So that's 10 over sine 60, and then horizontal equilibrium, cos 60 equals HDE over DE. Therefore, HDE equals DE cos 60, and from there we had DE. So DE cos 60 gives us the HDE. So I'll just fill those numbers in the next video. I've just got to about 10 minutes, so I'll finish this video here and then we'll carry on in the next video. So I think we found out we should have got, an HDE will equal CE. Yeah, so HDE, DE is in compression and CE is in tension. So I'll see you, sorry about the presentation. Please can you subscribe to the channel so that I can tidy up my presentation. It's got more. I need to monetize the channel. If you could help me get 1,000 subscribers, that would be really great. If you guys could help me get to 1,000 subscribers, that would be wonderful. Then I can improve on my presentation. I can put the notes up so people can download them and get them drawn up nicely, have a bit more time. And then hopefully you've still found this useful, and then I'll finish this off in the next video. This is another internal member forces, pin jointed forces problem to solve from chapter 2, linear analysis of structures. Thanks. See you in the next video. Please leave any comments. Thanks for watching. Thanks.